If you've been wondering how to run a floating wind turbine simulation in OpenFAST, then this video should give you a solid starting point. Today, we will work through our first floating wind example using the OC3 Spark platform and take a closer look at how turbines respond under a given design load case. So stay with me and let's get started. We don't have any ambitious objective for today. We just want to simply run the OC3 cert file for 180 seconds. After successful completion of that step, we would like to compute and plot time series for a few items. The first row will be the floating platform motions in surge, heave, and pitch degrees of freedom. After that, we would like to have a look on shear force and bending moment at base of the wind turbine tower, which generate by side-to-side and fore and aft motion of the tower and turbine assembly. When it's finished, I see value to look at different parameters, such as turbine rotor speed. When we have finalized with this kind of activities, we also would like to take a step further and try to visualize the turbine motion and generate a simulation video out of this. So what we need to do is to generate the suitable file format with the help of OpenFAST, and then we will load all of those files into a third-party software. Over there, we can generate our animation. You can see the turbine on the screen. So this is basically a tall cylinder shape spar buoy. And on the table, we've mentioned the general sizing as well as the inertia properties of this floater. If you are interested to have a look on complete hydrodynamic properties of this, have a look at this link. And if you're interested to know more about the 5 megawatt wind turbine on top of that, have a look into this file. So the floating platform will have 6 degrees of freedom. But for today, we just would like to plot time series for surge, heave, and pitch degrees of freedom. Additionally, we would like to see how fore and aft, as well as side-to-side motion of the wind turbine tower will generate moment and shear force at its base and plot the time series for this kind of force and moments. We have completely set up the OpenFAST in previous video, so we should be fine for this session. Let's just navigate to where we have saved that file. So this is the executable file of OpenFAST, and this is the CertTest folder. Today, we are really interested to have a look into this file. As I mentioned, we're not looking to change anything in this example except the runtime. So wave, wind, current, and any other configuration in FST file and associated file to that will keep as it was. Let's just open FST file with appropriate tools. For me, it's Notepad++. For you, it could be anything that you're comfortable with. Tmax or total runtime is 2 seconds. So I have to increase this to 180 seconds and save. In future video, we will look into different modules of OpenFAST and we will explain them in full detail. But for now, just take this one from me. Whenever you adjust the total runtime, you need to be mindful of your CState file. So basically, whenever you generate or import any wave time series into your simulation, the duration of that time series should be larger than your total runtime. So let's just double check that. As you can see, the wave Tmax or analysis time for incident wave calculation is 600 seconds. On the other hand, the total runtime of our simulation is 180 seconds. So 600 is way above 180. So we're on the safe side. We don't need to change anything. So 180 seconds for total runtime. We're not going to change anything else. The only remained item is the output file. So we scroll down. The output file format is on option 4, which is uncompressed binary. We would like to have a text file. So let's just change this to item number 1. If you recall from objectives, we also would like to generate some animations. In order to do that, we just to scroll further down. And under the very last header, we have visualization, in which we can have some control over those kind of animation out of OpenFAST. So what OpenFAST do is to generate some file format, which is VTK, and then we import those file format in a third-party software. As we can see here, the VTK type has been set on 2, which is basic mesh. That's not sufficient for us. We actually need to have some fine surface. So it should be option number 1, actually. And save. Additionally, we have control over the frame rate of the VTK output. I'm just going to leave it on 50 frames per second. And eventually, you need to be mindful of VTK visualization data output, which for now is on 0, so no output. But I would like to see some animation, so I have to put it on number 2 and save. That's it. You just need to be mindful. If you leave this on, I mean the visualization data output, it has started to generate your VTK files, and then you can create your animation with help of these files. But the file size would be large compared to the situation that you're not turning it on. So it would be difficult to save these VTK files with online services like emails, for example. And on the other hand, you should also be mindful of your runtime or CPU time. So when you have this on, it actually takes longer to solve your simulation compared to when you don't turn it on. So if you need it, use it. If you don't, leave it off. Because in realistic scenario, you might need to run any of this simulation for 1 hour or 3 hours. And it could be really time consuming for you if you want to also create some animation out of that. Anyway, for the sake of this example, we will leave it on because we have to do some activities afterward. Let's just save that with Control S and close the file. In order to run this, I need my PowerShell. And I will type fast, put a space. Then I have to either type this address and the file name or just drag and drop it. There are different ways to carry out the same activity. We're obviously more interested into the simplest one. Press enter. Now we just have to wait. All right, so OpenFAST terminated normally. We're good. Let's just close this. All right, so this is your output file, 38 megabytes, which is manageable. And these are the VTK files for animations, too many of them, which are, okay, they are 3 gigabytes. 3 gigabyte hard capacity was consumed for 180-second animation. Just imagine if you have to run this for 3 hours. And this is going to be only one DLC, one design load case. But you're going to have plenty different design load cases for a given wind turbine. So that's why I recommend not to use this unless you want to do any visualization for a short duration. Okay, back to result. Usually the first column is time, and it should be for the duration of your simulation. The rest of the columns would be the outputs. And for some of this, you happen to know them. So for instance, rotor speed could be easily read. But I mean, for surge, heave, and pitch, you have to look closer. So platform surge, heave, sway, roll, pitch, yaw, etc. And the other set of parameters was the tower base, side to side, and fore and aft, shear force, and bending moment, which should be tower base mx, my, and tower base fx and fy. If it's difficult for you to figure out which is which within these parameters, it's actually quite understandable. And there's an easy way to solve this. All you need to do is to go to Google and search for OpenFAST GitHub. Then navigate to OpenFAST. In this area, you need to search for docs, which is for documentations, other supporting, and scroll down. You have to look for this particular Excel file, outlist parameters, which includes a list of all the parameters that you can have as an output in OpenFAST. Well, these are distinguished as per different modules. And we will go through these modules in later videos. But for now, you just need to look into Elastodyne. And here, if I search for Tower base, okay, Tower base loads. Tower base for an F shear force in X, side-to-side shear force, which will be Y direction, as well as the moments. So tower base FXT, tower base FYT, MXT, and MYT. We can put them side by side. There you go. You can easily find them. And for the cases of the surge and heave and pitch, just search for that. Find all. Platform surge, platform sway, heave, roll, pitch, and yaw. So this Excel file could be quite handy for you. You may download it, or you may just copy a link and keep a copy of this link. So if it happened to be updated, or some of these happen to be removed, then you will have access to the latest version anytime. Back to our assignment. We should plot the rotor speed. Let's just hide this column. Select and go down for a really long time, or just select the first row, hold Control and Shift, and press down arrow. Yeah, so we have them all. And this happens to be your rotor speed. Perfect. Platform surge, heave, and pitch. We select first row, hold Control and Shift, down arrow. We have them all. And there you go. The very last parameter was the tower base shear and tower base moment. Tower base Fx, Fy, Mx, and My. And we don't need this one. Control Shift, down arrow. Well, obviously you can feel free and plot them in different figures. Then you will have better scale. Or you can put one scale on the right, the other on the left, distinguish them. It's up to you. And then we can reuse this plot in your report or PowerPoint or wherever you need them. So that's for that. And the very final step was to create an animation. So let's just do that one. We have the VTK file here, and we need to somehow visualize them. What I'm going to do is to ask my friend Google. And here, one suitable tool for me is ParaView. It's open source, so feel free to use it. Download. And what you actually need to download is one of these MSI files. So Windows. All right, let's install it. Okay, so let's find ParaView. Now that we have ParaView up and ready, we really need to do something with these VTK files. So I'm going to copy this address because we need it for later. And I will go here, File, Open, Control V, Navigate. We have different categories. Well, it's per timestamp. You don't need to be mindful about it. So just select blade surfaces as well as hub, horizon surface. Well, you know what? You actually need all of them. And press OK. You just need to turn them visible. And you can do coloring here. You can do pretty different stuff here. It's really up to yourself. The documentation for this software and lots of tutorial videos are available out there. You just have to find what suits best for you and try to work out for that. For instance, here we can change the coloring a little bit. I can keep the blades as white. Seabed surface could be something darker. The floater could be yellow. So Morrison surface needs to be yellow. Then we have to change the seabed to something different. And you have different tools here to make it look nicer, adjust the view, adjust different angle. For now, let's just keep it as is and create a video out of it. So I'm going to go to File again and Save Animation. I will put this on my desktop. Okay. Image resolution, if you want to put any palette on it. And then press OK. Perfect. Now that it's finished, let's see how does it look. Perfect. So obviously you can make this way better. You can adjust few viewpoints like side view, top view, ISO view. You can put some slides. You can adjust the coloring, increase the frame rate in your initial setup, and work on it a little bit to make it look nicer. But for the purpose of this session, I would say we are in a really good position. So thanks for watching, and I hope you find it useful. I'll catch up with you in the next episode.